Fiber rolls or straw wattles are one of the few best management practices that can be both erosion prevention and sediment control. When we use the straw wattle at the perimeter of our project, that's for sediment control purposes. In this installation, we're demonstrating a mid-slope fiber roll installation to shorten and reduce that slope length and thus prevent erosion. Track walking by itself serves a similar purpose. Rather than one long smooth slope, we break our slope into a bunch of smaller sections to reduce the rilling potential and eventual gullying. By interrupting that slope further with a straw wattle, we further reduce the slope length, thus reducing erosion potential. Now, fiber rolls will pond water, and in a slope application, we need to be careful that we don't create a number of ponds on our slopes. That's an invitation to have a washout, a gully, or a problem. So these wattles are installed slightly on contour, and we're directing all of our sheet flow and eventual stormwater flow into an adjacent vegetated area. This is a very handy way to break up your slopes and control stormwater flow at the same time. A straw wattle will ideally be placed in a shallow trench amounting to about the third of a diameter of the wattle. By placing our trench spoils uphill of our installation, once we get our wattle staked, we can bring those spoils back against the wattle and ensure that we get that embedment to the proper diameter. So we've prepared our trench and placed our wattle, and you can see that we're getting that proper depth to the diameter of the wattle. Now we're going to have the overlap, and this is a critical step that we see problems with in the field. Keep in mind, we've got our wattles placed so that we are going to direct stormwater off our slope, discouraging ponding on our slope, and it's imperative that we get that transfer from the upper wattle onto the lower wattle. The mistake that we see commonly is placement like this. The flow will be able to get between this joint and cause rilling or gullying of our slope. Now, once we get our stakes placed, we're using the center punch method, so our stakes will be every 4 feet on center. Then we'll bring our spoils back on the top side of this wattle, ensure that we get a nice tight seal. This will prevent any undermining of our BMP installation. Fiber rolls are pretty commonly used sediment control at the perimeter of our projects. They're also used for erosion control. They're one of the very few BMPs that can function as both. There's some important considerations to make sure we think about when we're installing our fiber rolls. The butt joints, it's extremely important to do an overlap as opposed to butting the ends together. As these things dry out, they tend to separate, and then we get a gap. That gap has allowed water to form a gully underneath these, completely washing out our installation. The stake and tie down method is handy when we don't want to dig the trench to put the wattle into. However, this has to be done properly too. We like to see rope, not survey line like this. And then the staggering of the stakes is critical, because what we're trying to do is cinch that wattle down to make sure we've got tight contact with the soil below it. We want to see a 2-foot spacing staggered, so every 2 feet there'd be a stake. That way I'm only trying to cinch down 2 feet of the fiber roll at a time. When we have our spacing this far, it's impossible to get enough tension and enough pressure to hold our wattle down, and that results in the gullying we see here underneath. So while they're handy and they're frequently used, they're often not installed properly, which leads to failures on our projects. More money for maintenance, more sediment cleanup. So when inspecting our wattles, this is about an ideal installation as we can get. Now, wattles will pond water when installed properly. You can see these are trenched in. We've got our staking 4 feet apart, and so we've got a nice tight seal. There's no visible rilling or undermining or gullies forming anywhere. The overlap is really critical because these wattles are installed slightly on slope. So we're actually directing our flow across the top of this roll out into our vegetated areas. That way we don't have to worry about those ponds overtopping. By doing that, we trap a bit of extra water here. We see the increased vegetation growth and expression and establishment here. So about as ideal as we could see. In fact, we're getting pretty close to our notice of termination. So an ideal inspection on these wattles today. So here's an example where we didn't get the overlap done properly. We've got our wattles set at a slight gradient to direct the flow off of our slope so we don't pond water here. Unfortunately, if we had any significant accumulation, it's going to pond here and sneak between our wattles. We want these shingled-like roof, have that transfer flow onto the next wattle. We got lucky here. The combined contributing drainage area isn't significant enough to put volume here to blow this out. but it's just by getting lucky. This is not by design. So in a proper installation, we would have these reversed and our flow would transfer right in the direction where we want it to go.